Hi dear students, how are you all? How all of you are fine. Today we are going to discuss chapter 5 chemistry. I have written a question on the board. You can see. First, I have drawn a part of the periodic table and there are few symbols: X, magnesium, aluminium, silicon, then Y, then S, then Z. The last one is argon. This is a part of periodic table. Here X, Y and Z are used as symbols, not the symbols of any regular elements. The first question is, which element between Y and Z is smaller in size? Explain. Number 2, which one will be soluble in water between XZ and YZ3? Analyze. Okay, so we'll start question number 1. Which element between Y and Z is smaller in size? Explain. First, we will identify what is X, Y, what is Y and what is Z. X. We know magnesium, aluminium, silicon, sulfur and argon. These elements are elements of third period. So all the elements of this table are in the third period. Third period. So magnesium of course this is the element of second group, magnesium, and aluminium, silicon, Y is just a symbol, not the regular symbol, and S with a sulfur, and Z then argon. This is second, and what is this? And silicon. Last one is argon. Of course this is the element of 18. And sulfur, this is element of 16 group. So Z will be the element of 17 group. And this one, silicon, we know it is the element of 14 group. So Y will be the element of 15 group. And here aluminium is element of 13 group. So this is magnesium and this is the element of second group. So this one will be the element of first group. So we have identified what are the elements and where they are situated. Okay, so here magnesium 12 atomic number. So X is here sodium. So atomic number of sodium is 11. And what is this? Is of course phosphorus, and this one chlorine. So we have detected what is X, what is Y and what is Z. Sodium, phosphorus and chlorine. First we will see the electronic configuration of phosphorus and chlorine. Phosphorus 15, 1s2, 2s2, 2p6, 3s2, 3p3. There are 2 electrons in the first shell, there are 8 electrons in the second shell, and there are 5 electrons in the third shell. So P, first shell, second shell and third shell. 2 electrons in the first shell, 8 electrons in the second shell and 5 electrons in the third shell. If I show electron configuration of chlorine, then we can get 1s2, 2s2, 2p6, 3s2, 3p5. Similarly, in the first shell there are 2 electrons, and in the second shell there are 8 electrons, and in the third shell there are 7 electrons. 2 electrons are more in chlorine. So if I go from left to right, the number of shell are same. For chlorine, principal quantum number is 3, and here principal quantum number is 3. So like chlorine, in the first shell 2 electrons, and in the second shell 8 electrons, and in the third shell 7 electrons. So number of shells are same, but number of electrons is more in chlorine. So if I go from left to right in the periodic table, then the size of atom or atomic size or atomic radius will be decreased, because there is a electrostatic attraction force among electrons and protons. In the same period, we know the shells are same, but the electrons is increasing if I go from left to right. So the attraction force will be greater if I go left to right. As a result, the atomic size will be decreased. We can see here there are 5 electrons in phosphorus in the third shell, and here 7 electrons in the third shell. So attraction force will be greater among electrons and protons in the third shell. And for phosphorus, of course there is a attraction force, electrostatic force, but this is less than chlorine. We know sulfur 16. Of course the atomic radius of sulfur is smaller than phosphorus, but atomic size of sulfur is greater than chlorine. That means if I go from left to right, it will be decreased, or if I go from right to left, this will be increased, because number of shells are same, but electrons number is increasing from left to right and decreasing from right to left. So we can tell that the size of the atom or atomic radius will be decreased if we go from left to right. We know before phosphorus there is another atom, this is silicon 14. So we can tell silicon, phosphorus and sulfur and chlorine. So we can tell in short that if we go from left to right in the periodic table across period, the atomic size or atomic radius will be decreased, because the number of shells are same, but number of electron is increasing. As a result, the electrostatic force will be increased, so the distance will be decreased. So this is the series. Size of silicon atom is greater than phosphorus, and atomic radius of phosphorus is greater than sulfur, and the atomic radius of sulfur is greater than chlorine. So this is the answer of first question. Now question number 2. Question number 2 is, which one will be soluble in water between XZ and YZ3? First, we will identify what is XZ and what is YZ3. XZ. XZ is sodium chloride, and YZ3 is phosphorus trichloride. So sodium chloride. Sodium chloride is a pure ionic compound. Pure ionic compound. An ionic compound forms two ions, cation and anion, in the solution or aqueous solution. But phosphorus type, this is a covalent compound. Covalent compound doesn't form two types of ion in the solution. So sodium chloride, this is solid Na plus in aqueous solution plus chloride in aqueous solution. Sodium chloride will form cations and anion in the solution, but phosphorus trichloride doesn't form two types of ion in the solution. Now water. Water is a polar compound. It will show polarity like this. 2 del minus, del plus and del plus. Why does it show polarity? Because there is a electronegativity difference between H and O, that means oxygen and hydrogen. That's why it shows polarity. So when we put sodium chloride in the outer, then it will be dissociated like this. Then sodium ion will be surrounded by the outer molecule, but this is positive, that means plus. So outer will surround like this. This is positive, so 2 del minus, del plus and H del plus. Look, H plus, sodium cation and oxygen part, oxygen side will come to the contact to sodium like this. Two del minus, del plus, 2 del minus, del plus and 2 del minus, del plus and del plus. So this sodium ion is surrounded by outer molecule, and this is plus and this is of course minus. Not this part won't come here. Now chloride ion. Chloride ion will be also surrounded by outer molecule, but vice versa. H del plus or H del plus, 2 del minus. Look, this is chloride ion, negative ion. So the positive part of the outer will come near to chloride ion. H plus and oxygen, H plus, 2 del minus and H plus, and like this, H plus, oxygen, 2 del minus, del plus and del plus, and here H plus, 2 del minus and del plus. So this chloride ion is surrounded by outer molecule, but hydrogen part has come near chloride ion because this is positive charge and it has negative charge. So like this, outer molecule will surround sodium chloride. But phosphorus trichloride, this is pure covalent compound. It doesn't form cation and anion in the aqueous solution. That's why it is not soluble in outer, and sodium chloride is soluble in outer. This is the answer of the question number 2.